In this problem 35 from the OpenStax textbook, there's a bit of repetition, but this is good to remember and learn how to use the ideal gas law. Whenever you're given one volume or one temperature or one pressure or something like this, you need to use the ideal gas law. The thing to remember is that the units of R is very important because this kind of guides your selection of the other things. R is equal to 0.0821 liters times atmospheres divided by moles divided by kelvins. Now we all have memorized that the temperature must be in Kelvin, but remember that your pressure must be in PSI. So we have kilopascals, we have torrs here, and so on, okay? So for part A, what do? We first sketch out what we have. The volume is equal to 0.100 liters, okay? And double check, yes indeed, we have the correct units, okay? Next, we have 307 torrs. Okay, so the pressure is equal to 307 torr. Now, you've probably already remembered that that's the same thing as millimeters of mercury. So just replace torr with mmHg. Now, we need units of atmospheres. So there's 1 atmosphere in 760 millimeters of mercury. Okay, so we divide by 760 and grab your calculator and just put that down there for future use. Okay, so we have 0.4039. Right now we're not rounding it off to, well, we could round it off to 3 sig figs if you like. Okay, 404 atmospheres. Okay, so it's in atmospheres, and now that's correct. Keep going. We have temperature. Temperature is 26 degrees Celsius. Okay, and we immediately want to add 273 to this to convert it to Kelvin. So that's 299 Kelvin. Okay, N is unknown in the ideal gas law, right? We're going to calculate that, and then at the end, we're going to convert that to grams at the end, because the problem is asking us how many grams of gas, okay? So that's the basics of this, okay? So first, we want to take the ideal gas law, and we want to divide both sides by RT to isolate the variable N by itself. So R cancels, T cancels out, right? So we have a new formula. N is equal to pressure times volume divided by the universal gas constant and divided by temperature. So let's go ahead and plug all of these in. So the pressure, remember, use the converted values that we did for these things. So pressure is 0.404 atmospheres. The volume here is 0.100 liters. Okay, R is that crazy 0.0821 with all these units. Okay, and the temperature here is 299 Kelvin. Okay, always make sure your units are compatible and canceling correctly. So atmospheres, liters, okay, kelvins, and we're left with moles. So that's good, all right? So what we get here as a final answer is going to be in moles. So grab your calculator, multiply these things out, and I always recommend double checking it. Let's see, how many sig figs should I have here? 3 sig figs. So let's go ahead and round that off to 1.65 times 10 to the minus 3 moles. Now my calculator displays small numbers in scientific notation. Okay, so that's the value for N. Let me double check this by punching it all into my calculator again. Okay, and we get 1.65 times 10 to the minus 3. And this is moles of CO₂. Okay, CO₂. All right, so now we want to convert to grams. So we use the periodic table, and we find the numbers off the periodic table for carbon and oxygen. And don't forget, there's 2 oxygens. Okay, so we're just going to do this on our calculator. Okay, I'm going to take 15.999 and multiply that by 2. And then I'm going to add a carbon, which is 12.011. And I get 44.009. Now, what does that number mean? It means that this many grams of CO2 is equal to 1 mole of CO2. Okay? And the equal sign there, right? This equivalency is going to be used in the following conversion. So we have 1.65 times 10 to the minus 3 moles of CO2. Okay? And we put our fraction bar there. So down below is going to be 1 mole of CO2, so that the moles of CO2 cancel. And up above, I'm going to have 44.009 grams of CO2. Okay, so the moles of CO2 cancel. So I'm going to take these two numbers and multiply them. All right, and I get a value of 0.0726. And I'm going to round this off to 3 sig figs. Okay. And so that looks good. Let's double check this on our calculator just to make sure we're getting the same number twice. And I get 0.0726 grams of CO2. So that's the final answer there, okay? So that was a lot of work. We had to identify the correct formula using the units of R. R is always going to be given to you on any exam. You're going to have to fix your possible units for the pressure and the temperature and possibly the volume. You're going to have to do algebra to solve for N. Once you have N, you're going to have to use the periodic table up here in green to convert from moles to grams. Thanks for watching. Please consider subscribing to my channel and have a great day.